Assalamu alaikum everyone. So this was the first question. The diagram shows quadrilateral ABCD in which angle BAD, this is angle BAD, is equals to BCD, and these two angles are 90 degrees. Angle ADC is theta, AB is 4, AD is 8 centimeters. The first part of the question is to show that the perimeter of the quadrilateral is given by this. So perimeter is sum of all the edges, all the outer boundary. So I have this as 4, I have this as 8. I need to find the remaining two sides. So I will break this into two parts. This will be 90, and I will break this here as this. So if this is 90, this is theta, this angle will be 180 minus 90 minus theta, that is 90 minus theta. If this is 90 minus theta and this is 90, so this angle will be theta. This obviously is 90 degrees. So from the perspective of this particular triangle, this is base and this is perpendicular. So I will name it B1 and this is as P1. Sine theta is P1 upon 8. So P1 is 8 sine theta. Cos theta is B1 upon 8. So B1 is 8 cos theta. Now I will look at the other triangle, this one. From this triangle's perspective, this is perpendicular and this is base. So from this triangle's perspective, sine theta is P2 upon 4. P2 is 4 sine theta. And from this triangle's perspective, cos theta is base upon hypotenuse, B2 upon 4. B2 is 4 cos theta. So now realize that this P2 will also be equal to this. So this P2 is 4 sine theta. This B1 is 8 cos theta. The whole of this length is 8 sine theta. But B2 is 4 cos theta. So this length turns out to be 8 cos theta minus 8 sine theta minus 4 cos theta. I hope this makes sense to everyone now. So this is 4, this is 8. The whole of this is 4 sine theta plus 8 cos theta. And the whole of this is 8 sine theta minus 4 cos theta. So perimeter is sum of all sides, 8 plus 4, 8 plus 4 plus 8 sine theta minus 4 cos theta plus 4 sine theta plus 8 cos theta. So P is 8 plus 4, that is 12. 8 sine theta plus 4 sine theta is 12 sine theta. 8 cos theta minus 4 cos theta is 4 cos theta. So we had to prove that the perimeter is 12 sine theta plus 4 cos theta plus 12, and this is proved. The next part of the question is to express P in the form of this. And hence find the value of theta for which perimeter is 19. So if perimeter is 19, it means that 12 sine theta plus 4 cos theta plus 12 is 19. 12 sine theta plus 4 cos theta is 19 minus 12. 12 sine theta plus 4 cos theta is 7. Now this has become a harmonic trigonometric identity question. So I will find R, which is 12 square plus 4 square, 144 plus 16 under root of 160. The angle is tan inverse of 4 upon 12, which is 18.4 degrees. And thus this turns out to be R, that is under root of 160 sine theta plus 18.4 is equals to 7. Now the question has transformed itself into a normal trigonometric equation. Sine theta plus 18.4 is 7 upon under root of 160. Step number 1, check the range. Is there a need to alter the range? Find the basic angle. Sine inverse of 7 upon under root of 160 33.6 degrees. Since we need to find theta and we are aware of the fact that theta is here, which is an acute angle. So theta plus 18.4 is 33.6 degrees. Theta is 33.6 minus 18.4 is 15.2 degrees. I hope this is clear to everyone. And this marks the end of the first question. In the next question, we need to prove this trigonometric identity. One plus sine 2 theta is 2 sine theta cos theta minus cos 2 theta is 2 cos square theta minus 1 upon 1 plus 2 sine theta cos theta plus 2 cos square theta minus 1. So if I expand these two, 1 plus 2 sine theta cos theta minus 2 cos square theta plus 1, 1 minus 1 cancels off. I am left with 2 sine theta cos theta plus 2 cos square theta. टू प्लस टू साइन थीटा कॉस थीटा माइनस टू कॉस स्क्वायर थीटा ओवर टू साइन थीटा कॉस थीटा प्लस टू कॉस स्क्वायर थीटा. अगर मैं इसमें टू माइनस टू कॉस स्क्वायर थीटा प्लस टू साइन थीटा कॉस थीटा ओवर टू कॉस थीटा साइन थीटा प्लस कॉस थीटा. 1 minus cos square theta plus 2 sin theta cos theta over 2 cos theta sin theta plus cos theta. 1 minus cos square theta is sin square theta. 2 sin square theta plus 2 sin theta cos theta over 2 cos theta sin theta plus cos theta. If I take 2 sin theta common in the numerator, I'll be left with sin theta plus cos theta upon 2 cos theta sin theta plus cos theta. This cancels off, this cancels off. I'm left with sin theta over cos theta, which is tan theta. And hence I have proved the identity. Then the question says, find the exact value of tan 22.5, which means that theta is 22.5. So 1 plus sine 2 22.5 minus cos 2 22.5 upon 1 plus sine 2 22.5 minus cos 2 22.5 is same as 1 plus sine 45 minus cos 45 over 1 plus sine 45 plus cos 45. 1 plus sine 45 is under root 2 upon 2. Cos 45 is also under root 2 upon 2. 1 plus sine 45, that is under root 2 upon 2 plus under root 2 upon 2. This cancels off. I am left with 1 upon 1 plus under root 2 upon 2 plus 1 upon under root 2 upon 2 is under root 2. Please realize that there should never be a root in the denominator. So I will multiply both the numerator and the denominator by the conjugate of the denominator. And hence this will turn out to be 1 minus root 2 over 1 minus 2. And the final answer will be 1 minus root 2 upon minus 1. 1 upon root 2 minus 1 is same as root 2 minus 1. I hope this makes sense and I hope this is clear. So this was the second question. The first part was to prove the identity and the second part was to use the identity to find the exact value of tan 22.5. The question says that if sine theta plus alpha is equals to 2 sine theta minus alpha, we need to prove this. So it's ideal that we should expand the compound angle identity. So this will become sine theta cos alpha plus cos theta sine alpha, which is equals to 2 times sine theta minus sine theta cos alpha minus cos theta sine alpha. We will expand the brackets. Sine theta cos alpha plus cos theta sine alpha is 2 sine theta cos alpha minus 2 cos theta sine alpha. So sine theta cos alpha minus 2 sine theta cos alpha is equals to minus 2 cos theta sine alpha minus cos theta sine alpha. Sine theta minus 2 cos sine theta cos alpha is minus sine theta cos alpha is minus 3 cos theta sine alpha. Minus minus cancels off. Sine theta upon cos theta is 3 sine alpha upon cos alpha. Sine theta over cos theta is tan theta. Sine alpha upon cos alpha is tan alpha. And this is proved. And hence, I have to feel like the king of the world. Then the last question, we are told to prove the identity that tan alpha plus beta plus lambda is tan alpha beta lambda minus tan alpha beta lambda and the whole of this. My advice to do this question would be to break it into two parts. Let's make this A and let's make this B. So this will become tan A plus B. So first I'll expand this. This will be tan A plus tan B over 1 minus tan A tan B. Now I will substitute A with alpha plus beta and I will substitute B with Y. 1 minus tan alpha plus beta tan Y. Now I would apply the double angle identity here again, compound angle identity here again, and this will become tan alpha plus tan beta over 1 minus tan alpha tan beta plus tan y over 1 minus tan y, and this tan alpha plus tan beta will be tan alpha plus tan beta over 1 minus tan alpha tan beta. So if I find the LCM, it will be tan alpha plus tan beta plus 1 minus tan alpha tan beta over, if I find the LCM here, it will be 1 minus tan alpha tan beta minus tan y tan alpha plus tan beta. Since both the denominators will be same, I will cancel the denominators. I will be left with tan alpha plus tan beta plus tan y minus tan alpha tan beta tan y over 1 minus tan alpha tan beta minus tan alpha tan y minus tan beta tan y. And this is what we need to prove. Tan alpha plus tan beta plus tan y minus tan alpha beta y over 1 minus tan alpha tan beta minus tan beta tan y and minus tan alpha tan y. And hence the identity is proved and I have to feel like the king of the world. I hope this makes sense and I hope this is clear. I would reiterate it. So that anyone who wants to revise it can easily do so. Tan alpha plus beta plus y is identical to tan alpha plus tan beta minus tan y minus tan alpha tan beta tan y upon 1 minus tan alpha tan beta minus tan beta tan y minus tan alpha tan y. So as I mentioned earlier, I will first take alpha and beta as A and I will take y as B. So this will become tan A plus B, which is same as tan A plus tan B over 1 minus tan A tan B. Then I will replace A with alpha plus beta and I will replace B with y. 1 minus tan A will be tan alpha plus beta tan y. I will start expanding tan alpha plus beta, tan alpha plus tan beta over 1 minus tan alpha tan beta plus tan y over 1 minus tan y tan alpha plus beta. I will expand this tan alpha plus beta, tan alpha plus tan beta plus tan y 1 minus tan alpha tan beta upon 1 minus tan alpha tan beta upon 1 minus tan y tan alpha plus tan beta over 1 minus tan alpha tan beta. I will calculate the LCM of the denominator. The numerator will remain tan alpha plus tan beta plus tan y minus tan alpha tan beta tan y over 1 minus tan alpha tan beta over, I will find the LCM, 1 minus tan alpha tan beta minus tan alpha tan y plus tan beta tan y over 1 minus tan alpha tan beta. ये दोनों डिनोमिनेटर सेम है तो कैंसिल हो गए. I am left with tan alpha plus tan beta plus tan y minus tan alpha tan beta tan y upon 1 minus tan alpha tan beta this is minus 1 minus tan alpha tan beta minus tan beta tan y and minus tan alpha tan y. This was the identity that we had to prove. I hope this is clear. I hope this makes sense. And I hope everyone has understood it. So this was the assignment or the test that was to be discussed. And I hope this is clear to all of you. Thank you. Take care. Allah Hafiz. I will see you all soon, inshallah. Allah Hafiz.